Coastal erosion as a natural phenomenon is a complex process that, as you have been able to learn in previous sessions, depends on factors such as wave energy and the direction in which it impacts the coast, climatological factors, sediment availability in the coastal system, and, as we will see later, it will also be the result of anthropogenic factors such as urbanization and the construction of engineering works in coastal areas. In order to establish that erosion is becoming a problem that affects or can affect and diminish the ability of beaches and other coastal ecosystems to perform their intrinsic functions and provide environmental services, monitoring coastal systems, measuring and evaluating their changes over time, is essential. The monitoring of the coastal system, its morphodynamics and hydrodynamics encompass a wide range of methods, tools, and sources of information. Some of these have already been mentioned throughout our course, particularly during ocean waves and tide sessions. But why the monitoring of coastal systems is so important? Monitoring the world's coasts is an important prerequisite for effective decision-making that enables the protection and sustainable use of marine resources. Scientific, credible, and open data is needed to assess the impacts of climate change such as coastal erosion, pollution, extreme events, and manage the ocean's valuable resources. Monitoring the beaches and coastal ecosystems regularly is a task that helps us understand their morphodynamics. A better understanding of the changes and evolutionary trends will enable us to identify whether erosion is part of the annual cycle, winter-summer, or if it was an episodic change in the beaches or dunes, or if it is a structural erosion issue. Coasts are increasingly subjected to both natural and anthropogenic influences, such as rising sea level, global warming-related storms, and changes in land use patterns like construction, deforestation, and agriculture. The intensification of erosion due to increased wave activity and storm intensity is causing coastal communities to experience more frequent and destructive flooding, degradation of water quality, and beaches with inadequate widths to fulfill their functions, among many other impacts. Even though erosion and sediment accumulation are natural processes, it is known that any anthropogenic influence exacerbates the environmental condition of the coast. Thus, population density and development activities along the coastal zone accelerate these processes, either semi-permanently or in a permanent and irreversible manner. Based on this, and in order to preserve the values of beaches and/or other coastal ecosystems, it's important to have basic information about the variables that influence their evolution. Hence, monitoring coastal erosion, and the entire coastal system in fact, becomes undeniable due to the broad range of impacts it has on the livelihoods of societies. In this regard, the coast can be studied in terms of its dynamics, or in terms of morphological changes near the coast. This requires an awareness of the interactions between environmental processes on land and in the open sea, such as wave energy and propagation direction, episodic weather events, and even trends in climate change. It also involves considering the characteristics of materials along the coast, as well as their sources and sinks. Additionally, it's important to account for the influence of human-made structures and how they can significantly alter the natural regime. Monitoring methods should be as comprehensive as possible to gather important information about regional bathymetry, along with natural features and materials. Coastal morphology and dynamics need to be quantified over time, and erosion risks should be assessed considering both present and potential future scenarios. All of this information will be valuable for understanding the evolution of the coast, and as input for designing and implementing projects focused on its protection against structural erosion.